This is a quick review of the exponent laws we should already be comfortable with by now. So our first law, the product of powers, states that when you have a to the power of m times a to the power of n, where a is any variable and m and n are any integer, this is equal to a to the power of m plus n. So for example, if you had x squared times x cubed, you would get x to the power of 2 plus 3, which is 5. Okay? Quotient of powers. This is like the product of powers, but when you have a to the m divided by a to the n, what you get is a to the power of m minus n. So if you had x to the power of 5 divided by x to the power of 2, you would get x to the power of 5 minus 2, which is 3. When you have a power of a power, that is a to the m to the power of n, this is equal to a to the power of m times n. So, if you had x to the power of 2 to the power of 3, this is equal to x squared times x squared times x squared, which is equal to x to the power of 2 times 3, which is 6. You can also see it was 2 plus 2 plus 2 as well. When you have a product, say a times b, and you are taking the power of that product, say you're taking that to the power of m, this is the same as taking a to the power of m times b to the power of m. Okay? So for example, if we have 2 times 3 to the power of 2, well, we know this is 6 squared, which is 36. This is also, according to the power over product rule, this is also equal to 2 squared times 3 squared, which is equal to 4 times 9, which is equal to 36. Okay? So a times b to the power of m is equal to a to the power of m times b to the power of m. Now we have the power of a quotient. If we have a over b to the power of m, similar to the last rule we had here, this is equal to a to the power of m divided by b to the power of m. So if we had 4 over 2 to the power of 2, this is equal to 2 to the power of 2, which is equal to 4. Well, according to the power of a quotient rule, 4 over 2 to the power of 2 is also 4 to the power of 2 divided by 2 to the power of 2, which is equal to 16 divided by 4, which gives us 4. We had a 4 in both terms, so we know that this power of a quotient rule is correct. Now here, this is the easy rule to remember. If you have a to the power of 0, this is always equal to 1, no matter what number a is. So you could have 8,374 to the power of 0. This will give you 1. You could have 1 to the power of 0. This still gives you 1. Okay? Even if it was just a variable x to the power of 0, well, this is still equal to 1. Now, powers and radicals is something that we should have learned in grade 10 by now, which states that a to the power of m over n, so a fraction here, is going to be equal to the denominator is our index of our radical, and the numerator is our power. Okay? So the nth root of a to the power of m, or it could be the nth root of a to the power of m. These two are the same, okay? So if we had x to the power of 3 over 2, well, this is equal to the square root of x cubed. Because if there is no index, it is assumed to be a 2, so you're taking the square root. When you have inverse powers, so you are taking the m root of a to the power of m, well, we know by our previous rule that this is equal to a to the power of m over m, which is just equal to a, or a to the power of 1. Okay? So if we have the square root of x squared, well, this is just equal to x. Okay? Because this invisible index is a little 2, and this becomes x to the power of 2 over 2, which is x to the power of 1. When we have a multiplication of a radical, so within our radical we have a times b, well, this is equal to the m root of a times the m root of b. Okay? So for example, if we had the cubed root of 8 times 27, well, this is equal to the cubed root of 8 times the cubed root of 27, which gives us 2 times 3, or 6. Okay? You can also check this by taking the cube root of 8 times 27, which is 216, which gives you 6. Thank you for watching the review of Exponent Laws.